All right, let's look at some example problems of objects that are experiencing free fall. So this first question says that we have a bird and it is holding a pebble while perched on top of a 380-meter tall building. How long will it take the pebble to reach the ground if it is dropped? What is the pebble's velocity after it reaches the ground? So again, we want to make sure that we are reading the question, looking for information that is going to lead us to some givens that we can write down, or we're looking for information that's just given to us as fact, as numbers. So a bird is holding a pebble while perched on top of a 380-meter tall building. So I personally like to draw pictures because I find them helpful, okay? So my building is 380 meters tall, and then here is my bird, and my bird is holding a pebble, all right? So it says that the bird is going to drop the pebble. So that means that my object is going to fall down like this to the ground. So the first thing that I'm going to write is that I have a vertical displacement of a negative 380 meters. Now, why did I make that a negative? Remember, displacement is a variable that has a direction. So at the end of the pebble's motion, it will be located at a position that is physically below where it started. So I'm going to list that as a negative 380 meters. The object is being dropped, so it is beginning at its highest point. So our initial velocity would be 0, and we know that it's falling because of the acceleration due to gravity. So this is the information that we should know just from the reading. Now it's actually asking us to solve for two things, so we're going to focus on the first question. How long will it take the pebble to reach the ground if it is dropped? So I am looking for my time. I'm looking for the time for the pebble to fall. So coming to my formula list over here, I'm going to find all of the equations that have a t for time, which is really pretty much every equation except for my VF squared formula. Now, just a friendly reminder, this first equation should only be used if we have an object that is not experiencing an acceleration, because we can see it does not have a place for an initial versus a final velocity or for that acceleration rate. So I'm not going to use that one. So I have narrowed it down to a few formulas over here. And then I want to just give you a friendly reminder. These two equations are the same set of variables, so that's really one option. Because I have decided to express my displacement both as a horizontal delta x or a vertical delta y, these two equations are actually the same option. And then I have my VF squared, which is not even an option, so I have two choices to pick from. In my list of givens, I have my vertical displacement, my initial velocity, and my acceleration, and I am looking for time. So looking at the equations that I'm looking to pick from, it's going to be this formula right here. It could be my displacement as an x, but I'm going to choose to use the one as a y. And I always recommend that you just kind of work your way through the formula to make sure that you do indeed have every variable that it's asking for. So I do have a vertical displacement. I do have an initial velocity. My time is my unknown. Of course, I know gravity, and once again, my time is my unknown, so everything is accounted for. So I'm going to write down my formula, and then I'm going to evaluate and substitute my variables. So I can choose to substitute my numbers and then do my algebra, or do my algebra and then substitute. For right now, though, I want to start off by just kind of simplifying. When I look at my list of givens, I see that I have an initial velocity of 0. So when I go to substitute into my formula, anything times 0 is 0. So this whole first part on the right-hand side becomes a value of 0. Because I am adding that, it basically goes away. Adding nothing doesn't change my value. So I am going to choose to work with the equation delta y is equal to 1/2 gt squared as my simplified version that I'm going to actually plug my numbers into. Okay, so this time around, I'm going to go ahead and plug my numbers in first, and then I will demonstrate how the algebra should look. Again, remember, eventually you will need to do your algebra without the numbers in place. So I have a negative 380 equals 1/2 of negative 9.8 times t squared. And t is what I am looking for. So this is going to simplify. And since I am multiplying this value times t squared, then I'm going to divide on both sides. So when I put this in my calculator, I should be typing in every single positive and negative. Please be careful if you are a person who tends to get a little lazy or relax a little with the details, because it does make a difference in these calculations. If you failed to make your 380 a negative value, then you would have calculated the same number as me, 77.551, and then there's more digits, but you would have calculated that to be a negative value. So when we go to solve for t, you would have attempted to square root a negative number, and your calculator will not allow you to do that. Why? Because that is not an actual function that can be performed by your calculator. Your calculator would error out on you. Now, I understand that in your math class, you may be able to continue with this problem and you would simply make it an imaginary number, but we don't have imaginary numbers in physics. Everything is real life motion. So if you ever find yourself solving for time and you have a negative number, or you're attempting to square root a negative, you simply need to go back and look at your signs that you plugged into your numbers, and I bet somewhere along the way you missed a negative. So once we put this in our calculator, and we are then going to take the square root of that number, we are going to get 8.8063, and then there are more decimals that I'm going to choose not to write down. So when we look at this number, I want to point out something. If you're following along with this and you're calculating as well, but your numbers came out slightly different, maybe you got 8.8, but the rest of the digits were a little off, or maybe you didn't quite get 8.8. There is a possibility that you fully understand how to do and what to do, but how you're utilizing your calculator can be just incorrect enough, or maybe not detailed enough to give you the correct final answer. So what I want you to do here is, instead of manually typing in 77.55 whatever, I want you to ask your calculator to take the square root of the last answer. So if you could locate the answer button on your calculator, we're going to square root our answer so that we don't have any variation in those decimals at the end of our calculation. We are going to round this for significant figures. So in this problem, we were only given one measured value, and it was measured with 2 sig figs, because ending zeros without a decimal are not significant. So we're going to round this final answer to 2 significant figures. So t equals 8.8 seconds. And that is the answer to the first part of the question. The second part of this question is asking me, what is the pebble's velocity when it reaches the ground? So now I have the same set of initial givens, but I'm asked to solve for the final velocity here. So you actually now have all the information that you need to use pretty much any formula on our formula list. I am going to walk you through how we would solve this if we were using the information that we were given in the original problem. So based off of the original problem, if I am looking for my final velocity, then that's going to be located here, here, which is the same, And that's really it. I only have a couple of options. So based off of the original problem, I am going to choose to use this equation because I was originally provided with my initial velocity, my acceleration, and my vertical displacement. So VF squared equals VI squared plus 2A. And I'm going to choose to write that as a Y, even though it's an X. It's the same thing. So now, whenever I go to plug in my numbers, my initial velocity, once again, is 0. So my final velocity squared is equal to 2 times a negative 9.8 times negative 380. Once again, make sure you include all of those negatives. So if I put this in my calculator, it's going to calculate out for me a value of 7,448. Now remember, this is equal to V squared. So the very last step here is for you to square root that value. And once I square root my answer, so again, tell it to square root and then use that answer button, I get 86.3017 and more digits in my calculator. So 86 meters per second is my calculated answer here. Now, before you box in that final answer, I want to give you a friendly reminder that you need to be making sure that every final answer is rounded for sig figs and has the appropriate unit. Right now, we are dealing with several variables that are vectors, so you also should stop and ask yourself, is this supposed to be a positive or a negative value? In this particular case, it is asking me for the velocity as a vector for an object that is falling or moving in the downward direction. So my final answer actually needs to be expressed as a negative number. Now you may be saying, well, Miss Espinosa, we did everything right and it came out to be a positive. How come the answer is supposed to be negative? Well, in this formula, if you look carefully, your velocities are being squared. You are square rooting a number in order to get that final answer if you're solving for velocity. So every value here is going to calculate as a positive, and unfortunately there is no way around that, okay? So because of the nature of the relationship in this equation, you are going to have to confirm that your final answer should be a positive or a negative number. If you are submitting an answer to me to be graded and you have expressed it as a positive 86 meters per second, that would be counted as a wrong answer because that would indicate that the object has a speed of 86 meters per second while moving vertically upward into the sky, and that is not what is happening here. For this next problem, we are going to be looking at an object that is thrown straight up into the air, which means it's then going to come back down. So this is going to be an up-down question, all right? So we have a ball that is sitting on the ground, and it is launched straight up so that it reaches the top of a 4.88 meter tall tree. So here's my tree, and it's 4.88 meters tall. So my object is going to start down here on the ground and it's going to go up to this location, to the top of the tree. What is the ball's launch velocity? So in other words, they want to know what velocity was given to the ball initially so that it was sent upward into the air. So listing my givens here, I have a vertical height of 4.88 meters. My object is accelerating because of gravity, always in the vertical direction. And they are asking me to solve for my initial velocity. Now for this question, they only gave me 3 variables to work with, so I'm missing some information. If I come over and I look at my list of equations, all of my equations have more than 3 variables, except for equation number 1, but again, that does not account for acceleration, so that will not be the formula that I choose to use for this question. So you can either go through the equations and figure out what you're missing, and then try and go and figure out what that missing piece should be, or you can just think about the scenario excuse me, and apply those main ideas that we discussed to see if you can go ahead and figure out the missing piece. In this first question, they're asking for the initial velocity, so we're starting on the ground. It is not an initial velocity of 0. However, I am supposed to know that the velocity, anytime the object is at its highest location, that moment the object has a velocity of 0. So since I can actually take this up-down motion and evaluate it in pieces or in halves, if I choose to say that we're measuring from the ground up so that the top is the end of the motion that I am considering for my calculation, I can put VF equals 0 on my list of information that I know that I have to work with in this problem. So based off of this information, I can then go ahead and calculate what that initial velocity is. I am going to choose to use a formula that has VI. So that's going to be pretty much every equation. I do not have my time, so that means that these guys are probably not going to be the right ones because they don't allow me, they require me to plug in a number for time. So just based off of that, I can quickly determine that this equation is the formula for me to use. So VF squared equals VI squared plus 2AY. And so I am going to substitute, actually this time I'm going to do my algebra first, okay? And the reason for that is because when I get ready to substitute, I see that my final velocity is 0. And so that means this left side goes away. That does not mean that your answer is 0. That just means I have 0 equals VI squared plus 2AY, and I now need to do some algebra so that I get the VI all by itself. So instead of adding my 2AY, I'm going to subtract my 2AY. So my formula is negative 2AY is equal to VI squared. And if you wanted, you could go ahead and handle that square and take the square root right off the bat. Give myself a little more room. So once we're here, we need to recognize that that last step would be to square root. So I am going to say that my initial velocity is equal to the square root of a negative 2 times negative 9.8 times 4.88. Now notice, gravity is always negative. My displacement in this case is a positive number because the object is going to end above the ground. So it is a positive displacement that I'm plugging in. But by moving that value over to the other side of the equation, I have provided a second negative so that when I go to put this in my calculator, it will not error out on me. Instead, it will actually allow me to perform this calculation because it will be square rooting a positive number. So this is going to give me 9.7799 ... more numbers. So rounding this for sig figs, I was only given one measured number in this problem, and it is the 4.88. So I'm going to round this for 3 significant figures. And it is supposed to be a positive answer because this is the velocity that sent my object upward. The next question says, what is the ball's hang time if it falls back down to the ground? So now it is asking me to find the time, but what does it mean by hang time? Hang time is another way of asking for the total time. So that means they want me to allow my object to go up and come back down. So here's where, remembering the main idea about the velocity, anytime an object is thrown up and returns to the same vertical position, I have now calculated my initial velocity to be 9.779 ... So that means when the object comes back down, it is going to have a final velocity of a negative 9.779 ... Okay, it is moving through the air affected by the acceleration due to gravity. And they are asking me for the time. So I am going to come back to my list of formulas. Again, I'm not going to use the equation up at the top because it does not allow me to account for acceleration. Based off of the information that I have to work with and the fact that I'm looking for time, it's going to be one of these two formulas. Remember, they're the same set of variables. I will choose to use A equals VF minus VI over my time because it allows me to very quickly manipulate this equation to solve for time. When you're done with your algebra here, essentially what happens is that time trades places with your acceleration, and this is how the formula is rewritten. So when I go to plug this in, it says t equals, my final velocity is a negative 9.779. That is my final velocity minus my initial velocity, which is a positive of this value. Now, sometimes students just kind of jump the gun here and they assume, oh, that means that I have a numerator of 0. That would be saying that it took 0 seconds for the ball to go up into the sky and then fall back down. We know that that cannot be the case. Do the math, that actually ends up doubling your value for your numerator. So please make sure that you are paying careful attention and executing the math correctly. And then I'm going to take that value and I'm going to divide it by negative 9.8. So for this particular question, my numerator is going to simplify to a negative 19.55, and there's more digits there, divided by a negative 9.8. So you can see that even though I'm solving for time, my values are still going to give me a positive number provided that I have executed my math correctly. This is going to give me a value of 1.9959 blah blah blah. So my final answer rounded for sig figs, once again, the original typed problem gave me 3 significant figures. So 199 followed by a 5 means that I'm going to round this up. So pay close attention to how we write this final answer. This gets bumped from a 9 to a 10, which bumps this to a 10, which bumps that to a 2. So 2.00 seconds.